Hey guys, welcome to our fourth video on graphing motion. For this video, we are going to basically continue the lab that you started, or that you will start on Tuesday. So we are going to look at a position time graph, kind of like the one that you're going to be creating on Tuesday, and analyze it. So I drew a graph. Now your graph had 6 different sections of motion and my graph only has 4. So I'm just going to kind of talk to you a little bit about what's going on with each of these graphs. This first blue line, you can see that where velocity is positive here. Okay, we're going forward. And then we're also speeding up because my slope is getting steeper. So since I'm speeding up, that means my acceleration must be in the same direction as my velocity. Then this red line here, I can see that I'm changing my motion here. I am still moving in the positive direction, so my velocity is positive. What's my acceleration? Well, I'm not getting a steeper slope. My slope is starting to flatten out. Do you see that? It's starting to get flat here. So that means my acceleration is causing me to slow down. The only way I would slow down is if my acceleration sign was opposite of my velocity sign. This green line here shows that our velocity is not changing. As you can see, my position is at 7, and so it stays at 7, it doesn't change. So I'm really not moving at all. So here my velocity is 0, and I do not have acceleration at all. Okay, there's no changing in my speed. My yellow graph is similar in that my slope of this line, it's supposed to be a straight line. Sorry, it looks squiggly, but it's supposed to be a straight line, so that means my slope's not changing. My velocity here is negative. It's going downward, but it's not speeding up and it's not slowing down because there's not a curve, right? It's a straight line. So my acceleration, again, that's supposed to be a circle with a line through it. I don't have any kind of acceleration in any direction because my velocity is constant. So both the green and the yellow line, velocity is constant. The yellow line shows that my velocity is constant in the negative direction, and the green line shows my velocity being constant at 0. Okay. So what I want us to do right now is kind of mimic the lab that we did. We're going to find velocity points, and I'll show you why we're going to find that in just a second. So for right now, we want to find the velocity at each of these points on the graph. And so to do that, for the blue graph, since my velocity is changing, I can't just use this point as my initial and this point as my final because my velocity is changing along the way. As you can see, the slope changes. So I'm going to find my velocity at this section and then at the end. The first second of this motion and the last second of the motion. So here's second 1, 2, 3, 4, and so on. So I can see my time for this first section. It's the time change is 1 second. Remember, this is our equation. So my time change, my final time is 2 seconds. My first time is 1 second. So my change is 1. And then what's my position? Well, I start at position 0. So that's my initial position. What's my final position? Well, it looks like it's right here at 1.5. I mean, not 1.5, half. So 0.5. So 0.5 minus 0 is 0.5. So 0.5 divided by 1 is 0.5. So this is my speed at this section. So at this section, my speed is 0.5. Now let's look at the end section. I'm going to do the same thing. Oh, I'm sorry. I kind of messed up my numbers here. This should be 0, 1, 2, 3, and 4. So this was really 0, and this is really 1, but it still gives us 1, so my value is not changing. All right, now let's look for our second velocity. We're going to look at the end of this section of motion. Our final time is 4 seconds. It's final minus initial. My initial time here is 3 seconds. And then what's my position? Well, my initial position here at 3 seconds, it's 2. See that? 2 meters. So it's final minus initial. My final point right here at 4 seconds, my final point is right at 4. So 4 minus 2 is 2. And 4 minus 3 is 1, so my velocity is 2. So I started at 0.5 meters per second, and then I went to 2 meters per second at the end. Now let's look at our next range of motion. We're going to do the same thing. We're going to look at the first second of this motion and then the last second of this motion. So this is 6, 7, 8, 9. Okay. So for our third velocity, we start at 4 seconds. We end at 5 seconds. Our position looks like it's starting at 4 meters, and our last position is ending at right here, which is 6 meters. 6 minus 4 is 2, 5 minus 4 is 1. So our initial speed here is actually the same. It's 2 meters per second. Okay. Then, and it kind of actually looks like that, right? Because it looks like I've almost drawn like almost a straight line here, so that kind of makes sense that it's constant. Okay, my fourth section of velocity, I'm going to look at the last section of this motion. So it's between 8 seconds and 7 seconds, so it's always final minus initial. And then I start here, and then I finish here with my position. So it looks like I'm starting at maybe 6.5. My final position is 7. So I end up with 0.5. So this speed right here is 0.5. So you can see from 0.5 to 2 I sped up, and then from 2 to 0.5 I slowed down, right? So this makes sense. I'm speeding up and then I'm slowing down. Now let's look at this section. Well, this section's easy. I already told you the velocity was 0 meters per second. We could do the math for it, but you're just going to end up with 0. So now the second graph, we don't need to look at 2 different sections. Why? Well, because the velocity is constant. It's going to be the same. So whether I look at this section of the graph, or this section of the graph, or this section of the graph, it doesn't matter what section of the graph I look at, I'm going to get the same answer. So I only need to do it once. So if I only need to do it once, I'm going to look at the whole part. This will be my initial point. This is my final point. Okay. So what time span am I looking at? Well, this is 11 seconds, 12, 13, and 14, and 15. So I look like I'm starting at 12 seconds right here. That's my initial. My final is 15 seconds. My initial position is right at 7. My final position, it actually doesn't go down to 0, it goes down to 1 right here. So I have negative 6 divided by 1, which is negative 6. So this speed is negative 6 meters per second, and negative makes sense because I see that I'm going downward on my graph. All right, we're going to use these values. We calculated 6 different velocities, and what we're going to create is a new type of graph called a velocity versus time graph. So velocity is going to be on the left side. This is velocity right here. And this is time. Because we have, let's look at our values for velocity. We have some weird values. We have 0.5 meters per second, we have 2 meters per second, we have 0 meters per second, and we have negative 6 meters per second. So I want to make my graph here realistic to where I can fit all those numbers on it. So let's see, let's make this negative 6 down at the bottom. So this is negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. So all of them can fit. And then my time axis I didn't change. I left it the same. It starts at 0, 1, 2, 3, 4, and it moves on like that. So let's go ahead and graph a velocity time graph. How do you do that? Well, once you have velocity values, which we have, you're going to put the velocity value on here for however much time it took up. So let's see, at 1 second and at 0 seconds, our speed was 0.5. Another way to look at it is look at the graph. During this section, that's 0 seconds and 1 seconds, our speed was 0.5. So let's mark that. Between 0 and 1, our speed was 0.5. Okay, well, here is 0. So 0.5 would be right here. So our speed was 0.5. And I'm drawing it as a straight line. It was 0.5 between 0 and 1. Okay, what's our next point? Well, our next point I did in red. Oh, nope, it's over here in blue. Between seconds 3 and 4, my speed was 2 meters per second. Well, let's look on the graph here, just to make sure. Between seconds 3 and 4, my speed was 2 meters per second. So let's go ahead and graph that. Between 3 and 4, that's this interval right here, my speed was 2. 3 and 4, my speed was 2. So we said, where's 2? 2's right here. So 3 and 4, my speed was 2. This is 2 meters per second. This is 0.5 meters per second. And then you can just connect them like this. All right. Now let's keep on moving on. Next, my third point, I was going 2 meters per second in between seconds 5 and 4. So look here, between 4 and 5, right here, 5 and 4 seconds, I was going 2 meters per second. I'm going to put this in red. So between 4 and 5, right here, I was going 2 meters per second. Then, between seconds 7 and 8, I calculated my speed was 0.5 again. So this is 6, 7, and 8. So what did I say? Between 7 and 8? Yeah, 7 and 8. So right here, my speed was 0.5 again. It's kind of a weird line. It's supposed to be a straight line. So I'm marking down all of my velocities. I have a couple more. It looks like my fifth velocity was 0. Okay, what time was that? What was that time interval? Between seconds 8 and 12, my velocity was 0. So I'm starting at 8. I'm going to go all the way to 11, 12 seconds. I need to show it to be 0. And just connect it like that. And then my last one, my sixth velocity right here, was between seconds 12 and 15. My velocity was -6. That's what we calculated down here, -6. So between 12 and 15, right here, mine was -6, which is actually right down here on the bottom. This is what a velocity time graph looks like. What it tells me is it's only graphing velocity. So you can't look at this and analyze it like you would a position time graph. You have to look at it and say, okay, I started with a speed of 0.5. Then I sped up and I got to a speed of 2 and I stayed at that for a few seconds. Then I slowed down to the speed of 0.5 again. Then I immediately changed to a constant speed of 0. Then I changed to another constant speed of -6. Okay, so now that we have a velocity time graph, we can actually calculate acceleration at each of these points. So that's what we're going to do. We're going to calculate acceleration at each of these points. Now remember, what's the formula for acceleration? Well, I'll put it right here for you. Acceleration is your first speed minus your second speed divided by your, that's not right. F doesn't stand for first. Your final speed, I'm sorry, minus your initial speed divided by your final time minus your initial time. So that's what we're going to do. We're going to find the speed at each of our 4 sections. I want to know the acceleration here. Whoops, I should make that a little bit further. Let's say I want to know my acceleration here. That's my first acceleration. Then I want to find my acceleration here. That's my second acceleration. Then I want to find my acceleration here. It's my third. Then I want to find my acceleration here. That's my fourth. And I should have kept the same colors. Like this part here should have been green. And then this part here should have been orange. Sorry, I did not keep my colors consistent. So let's calculate acceleration. Let's first look at the blue line. What was our initial speed? We started at 0.5. So that goes here. What was our final speed? It was 2. So 2 minus 0.5. Now we have to divide by the change in time. What was our start time? It was 0. What was our final time? Well, it was right here at 4. So 2 minus 0.5 is 1.5 divided by 4. And let me grab my calculator. Okay, so I put it in the calculator, and I get 0.375, and that's acceleration, so that's meters per second. So that's a kind of a slow acceleration. That means you're not speeding up super fast, which that's fine. Now let's find our second acceleration. Now, if you're, well, let's go ahead and do it. So, looking at our graph, find our second acceleration. You know, we need our, what's our formula? Here we go. We need our final speed minus our initial speed. Our final speed is 0.5. Our initial speed was 2. Our final, and then we divide it by our final time minus our initial time. Our final time here was 8 seconds. Our initial time was 4 seconds. Then I subtract, and I'm going to get negative 1.5 divided by 4, which gives me negative 0.375 meters per second squared. Now, interesting, why did I get the same value and one's positive and one's negative? Well, you could have probably just seen that by looking. We're doing the same values here, and they're over the same time interval. So, our last acceleration. We do our final speed minus our initial speed. What's our final speed here? It's 0. What's our initial speed? It's also 0. Remember, that's why I just wrote one number. 0 minus 0. And then our time is, our final time here is 12 seconds. Our initial time is 8. And then when I do 12 minus 8, I get 4 seconds. So 0 divided by 4 is just 0. That means I don't have any acceleration. Why does that make sense to have 0 acceleration right here? Well, because it's constant. Remember, if speed is constant, our acceleration is 0. So down here, our speed is also constant, right? It's at -6, so we should assume our acceleration is going to be 0. But let's double check. Our initial speed is -6, and our final speed is -6. And our initial time is 12. Our final time is 15. That becomes 0 divided by 3, which is just 0 meters per second squared. Okay, I'm going to go ahead and box these. This is our first acceleration. This is our second acceleration. This is our third acceleration. And our fourth acceleration. Now, lastly, we're going to graph the acceleration time graph. So an acceleration time graph just writes down what's your acceleration at the certain times. Well, let's go ahead and mark down the times for these. At what time were we having this acceleration? Well, we can look, and it's 4 seconds. Between 0 seconds and 4 seconds, I had this acceleration. What about this acceleration, the red one? Well, it was between 4 seconds and 8 seconds here. So between 4 seconds and 8 seconds, I have this acceleration. My third acceleration was between seconds 8 and 12. And then my last acceleration was between 12 and 15. Okay, so I'm going to go and graph that. So my first 4 seconds was 0.375. So let's just say that this is 0 and that over here it's 1 meter per second squared. So this is 0.5 meters per second squared. So this is 0.25 meters per second squared. So if we're talking about 0.375, we're looking somewhere right here, right? So that lasts for the first 4 seconds. Right, this is 0, this is 4. Then I do the same exact value, but it's negative, and it's between seconds 4 and 8. So let's say this is -1 meter per second squared. let's say this is negative 0.5 and this is negative 0.25. So negative 3.75 is somewhere right here. So somewhere right here, and it's between seconds 4 and second 8. So 4, 5, 6, 7, 8. So between 4 and 8, I have negative 0.375, and this was a positive 0.375. And I'm just going to connect the line right there. Then I have acceleration of 0 and 0. So really it's 0 from 8 seconds to 15 seconds. So I'll just put it in green. 0 meters per second squared. All of these are meters per second squared. So that is how you take a position time graph, like this one right here. You change it into a velocity time graph, and then you finally change it into an acceleration versus time graph. And you'll do it by finding your velocity at different points, then using those velocities to find your acceleration at different points, and then graphing that acceleration. And that's what we're going to do on Thursday with our lab. That's it. Have a great day.